All right, let's do a quick recap of osmosis. So hopefully we all remember that molecules move from an area of high concentration to an area of low concentration. That is, until they reach equilibrium on both sides of the membrane. You also know, or maybe you need reminding, but you should know that cells are always surrounded by water. They have an aqueous environment inside the cell and outside of the cell. Lots and lots of water, very abundant. And so, of course, that leads us to thinking about diffusion and the diffusion of water, which is osmosis. And when you think of osmosis, you need to be mindful of three key terms. And those key terms are hypertonic, hypotonic, and isotonic. Hypertonic is referring to the solute, so that's your high concentration of solute, low concentration of water. Hypotonic's the opposite. Having low solute frees up a lot of the water molecules, like the water's not stuck to a sodium ion anymore, it's free to move around, so that increases your water concentration. And then isotonic means that you have a balanced concentration of solutes and water on both sides of the membrane. So when we think of these terms, we need to be thinking of them in terms of what's going on inside the membrane or inside the cell and what's going on outside the cell. So here we have a cell, and it's surrounded by a hypertonic environment. So this is like a great example of why they tell you not to drink salt water if you're stranded in the middle of the ocean. You're drinking that salt water, you're basically bathing your cells in a hypertonic, super salt concentrated fluid. That makes the inside of the cell, by comparison, even though there's plenty of salts and sugars and things in your cells, that makes the inside of the cell hypotonic by comparison. So water is going to flow out. So let's just save that in the corner there. On the flip side, if the inside was hypertonic as compared to the outside, meaning the outside's hypotonic, so say you've stuck your hand into some pool water. After a while, your hands are going to start to get all wrinkled because your cells are soaking up the water and they become so large that they wrinkle on the surface of your fingertip. Blood cells in pure water can explode. They can certainly swell and lose their shape. That's because water is not moving out, it's moving in. So, water basically, there's a pattern here, moves from hypotonic solutions to hypertonic solutions, from high water to low water, flowing down the concentration gradient until it reaches equilibrium and you have isotonic solutions, balanced solutions on both sides of the membrane. This is why if they were to take you into a hospital, say you had a horrible stomach virus and you needed to be rehydrated, I hope that never happens to you, but if it were to, they would not put you on pure water. They would give you a saline solution, something that was isotonic with your body fluids and could be easily absorbed by your cells in a very balanced way, not putting your blood cells at risk of exploding. That would be very bad. So this is something to keep in mind when you're looking at those osmosis questions. Just slow down a little bit. Think about these terms. Remember, all the hyper and hypo and iso refers to the solute concentration, and whatever is around the cell is going to be the opposite.